Okay, so let's dive into these Azure Functions sources you sent. You've
Okay.
got articles, code samples, even some forum discussions.
Wow, that's quite a variety.
Yeah, it seems like you really focused on building modern web applications, especially with serverless architectures and real-time updates.
That's definitely a hot topic right now.
I'm seeing tons of info on triggering functions, securing them, and squeezing out the best performance possible.
And it looks like you're interested in alternatives to those old school polling techniques too.
Yeah, I'm sensing a real quest for efficiency here.
What I find really fascinating is how these different technologies, Azure Functions, SignalR, Cosmos DB, they all come together to solve these common problems that developers are facing,
Totally.
in modern web app development.
So are you ready to unpack all this?
Absolutely. Let's dive in.
Perfect.
Okay.
Now, the first source dives into the limitations of a traditional polling-based approach.
Oh,
It
okay.
uses the example of a stock ticker, constantly checking for updates every 5 seconds.
5 seconds. That doesn't sound so bad.
It doesn't sound like much, but all that back and forth,
Yeah, I could see where that would lead to problems.
it creates so much overhead.
Like constantly checking your email
Yeah, it's like constantly refreshing your inbox, hoping for new mail.
instead of just getting a notification.
Exactly. And this source points out that as your application grows, things get worse with polling.
Right.
More API requests, more page refreshes, more data moving around.
And that can really bog things down, especially with multiple users.
It's like rush hour traffic, but for your web application.
Yeah, everything slows to a crawl.
Exactly. I'm sure anyone listening who has used a slow web app knows this pain.
Yeah, absolutely.
So how do we escape this polling trap?
Well, that's where Azure Functions come in, and they offer a much more efficient solution.
Oh, okay.
So instead of constantly checking for updates, your code runs only when a specific event happens.
I see. So it's event driven.
Yeah, and there are all sorts of triggers for Azure Functions.
This source lists a bunch: HTTP requests, timers, messages from a queue.
Even changes in a database.
The possibilities seem endless.
And the great thing is you only pay for the compute time when your code is actually running.
No more idle servers just waiting around.
It's a total game changer in how we think about building and deploying applications.
Okay, I'm seeing how that's more efficient, but what about real-time updates? Making an application feel truly dynamic.
That's where Azure Signal Service comes in.
Oh, tell me more.
It allows you to push updates to connected clients as they occur without any polling.
So instead of the client constantly asking the server, anything new? Anything new?
Right.
SignalR opens a two-way channel where the server can say, hey, here's an update.
Exactly, and it handles all those complex connection management details for you.
The source even mentioned it can handle different types of clients like web browsers, mobile apps, even desktop applications.
Yeah, Signal is pretty versatile like that.
It's like upgrading from walkie-talkies to a live video chat.
Yeah, I like that analogy.
The information flows instantly.
That's the power of real-time communication.
This is a game changer for user experience.
It really is.
So we've got Azure Functions reacting to events, SignalR pushing those updates.
Where do we go from here?
Well, let's talk about building more complex logic and workflows.
Now we're getting to the good stuff.
Have you ever built an application that involves multiple steps, approvals, maybe timeouts?
Oh yeah, those can get pretty hairy.
It can be a real headache to manage all of that.
Right, especially in a traditional application.
So how do we simplify things?
Well, that's where durable functions come into play.
Okay.
They extend the capabilities of Azure Functions to make building these complex processes a lot smoother.
And you still keep those serverless benefits.
You got it.
I see you have a couple of sources on durable functions here.
Yeah, take a look.
They mention patterns like function chaining and fan out, fan in.
Those are some powerful concepts.
Can you break those down for me?
Sure. Think of function chaining like connecting Lego bricks. Each brick is a function, and you link them together in a specific order.
So the output of one function becomes the input for the next?
Exactly.
And what about fan out, fan in?
That looks great for running multiple tasks in parallel.
Can you give me an example?
Imagine you're processing an online order.
Okay.
You need to verify payment, update inventory, and notify the shipping department.
And all of those things can happen at the same time?
Right, you don't have to wait for one to finish before starting the next.
That's much more efficient.
Exactly. And then, once all those tasks are done, you can gather the results and send a confirmation email to the customer.
So it's like splitting up the work and then merging it back together.
You've got it.
Durable functions handle all that complexity behind the scenes.
It simplifies things dramatically for developers.
I see you have another source here that specifically talks about an approval process using durable functions.
Yeah, that's a great real-world example.
Can you explain it a bit?
Imagine a document that needs to be reviewed and approved by multiple people. Durable functions can manage the entire workflow,
Like sending the document to each person, tracking their responses,
handling timeouts if someone doesn't respond.
even escalating it to a higher up if necessary.
It's all about building robust workflows that can handle those real-world complexities.
So it's not just about automation, it's about building in those human interaction points.
Exactly. It's a combination of both.
Okay, I'm starting to see how durable functions can really take things to the next level.
They're a powerful tool in the serverless world.
But before we get too deep into the weeds of workflows, I want to zoom out for a moment.
Okay.
I want to talk about architecture.
The big picture.
Exactly. I noticed this source here about Azure API management.
Oh, yeah. That's an important piece of the puzzle.
Especially with all this talk about microservices.
You're right. Microservices are becoming more and more popular.
But how do we manage all those separate services?
That's where API management comes in.
This source lists a bunch of challenges that API management solves, but honestly, some of those terms are a bit over my head.
Oh, which ones are giving you trouble?
Client coupling, inconsistent API behavior.
Okay, I can clarify those.
Yeah, please explain.
Imagine you have a mobile app that relies on an API.
Okay,
Every time you change that API, you have to release a new version of your app.
right. That can be a real pain.
It is. That's what we mean by client coupling.
Okay, I'm starting to see the problem.
And API management solves this by acting as a middleman.
I see.
It lets you update your backend services without breaking your client applications.
So it decouples those things.
Exactly. Plus, API management ensures that your APIs all behave consistently, and it centralizes your security implementations.
So it's like a well-organized control center for all your APIs.
Exactly. It helps manage complexity and ensure everything runs smoothly.
Speaking of security, I see this source digging deep into securing webhook payloads.
That's an important topic.
It talks about GitHub using a secret to create a unique hash signature for each payload.
It's like a digital fingerprint that validates the authenticity of the message.
So you know that the information hasn't been tampered with.
Exactly.
Especially when you're dealing with sensitive data.
You don't want just anyone triggering your functions.
The source says the receiving function should compare the hash signatures.
Right, to make sure they match.
It's a relatively simple way to add another layer of security.
But it's super effective.
Okay, we've covered so much already: polling alternatives, the power of Azure Functions, Signaler, API management. But before we wrap up this part of our deep dive,
Okay?
I want to touch on a few best practices for Azure Functions.
Oh yeah, optimization is key.
Exactly.
Getting the most out of your functions.
This source suggests managing connections to external resources really carefully.
It's all about efficiency, right?
Yeah, it says creating new connections all the time can really hurt performance.
It's like leaving all the lights on when you're only using one room.
Great analogy.
It's a waste of energy.
The source also says to avoid shared storage accounts for your functions.
Ah, yes, that's important.
Can you elaborate on that?
Sure. Imagine sharing a single-lane road with a bunch of other cars.
Okay,
It's going to cause a bottleneck.
I see. It slows everything down.
Exactly. It's much better to give each function its own dedicated lane.
So they can operate independently.
And quickly, another tip is to process messages in batches
Ah, that's like going grocery shopping with a list.
instead of running to the store for every single item.
Right, you make one trip and get everything at once.
It's much more efficient.
I'm with you on that.
And finally, don't forget about scaling settings and monitoring.
The source emphasized those too.
It's like having a regular health checkup for your functions.
You can catch problems early
Exactly. And make sure everything is running smoothly.
before things get out of control.
Right, you need to stay on top of things.
Now, we were talking about the importance of configuring storage correctly.
That's a fundamental aspect of Azure Functions.
Can you elaborate on what configure storage correctly actually means?
Absolutely. One crucial factor is choosing the right storage connection settings.
There's more than one option.
Yep, there are different ways to connect your function app to its storage.
And I'm guessing the best approach depends on the situation.
Exactly. It depends on things like the size of your application, how often it scales, and the amount of data you're dealing with.
It sounds like there's a lot to consider when it comes to storage.
There is. But don't worry, we'll delve into those storage options more deeply in the next part of our deep dive.
I can't wait to hear more about it.
It'll be a fun ride, so stay tuned.
All right, I'm excited to continue this exploration.
Me too. Let's take a break and come back for more Azure Functions goodness.
Sounds like a plan.
See you soon.
Okay, so we left off talking about how important it is to get your storage set up right for Azure Functions.
Yeah, it's like building a house.
You need a strong foundation.
If the foundation is weak, the whole thing could crumble.
I'm also curious about something else I saw in these sources.
What's that?
The range of programming languages Azure Functions supports.
Oh yeah, that's a big deal.
It seems like it gives developers a lot of flexibility.
It's essential. Azure Functions don't box you into using just one language.
Do you happen to remember all the languages it supports?
Well, there's C# for sure, Java, JavaScript.
I was looking at Python code earlier, so I know that's one of them.
Yeah, Python's definitely supported, and PowerShell too.
Wow, that's quite a list.
And if your favorite language isn't on that list, they have custom handlers.
So they've really got you covered.
They try to.
Does supporting so many languages make things more complex, though?
It does add a bit of complexity, but the benefits usually outweigh the challenges.
How so?
Well, developers can choose the language that fits their project best.
And their team's expertise.
Right, which can lead to more efficient development.
That makes sense. Now, something else that came up was scaling limits.
Uh-huh.
We've talked about how scalable serverless is, but I guess there are boundaries?
Of course, there are always limits.
What kind of limits are we talking about?
Well, it depends on your hosting plan.
Oh, right, the different plans.
If you're on the consumption plan, the limits are different than, say, a premium plan.
Can you give me a specific example?
Sure, like the maximum number of instances your function app can scale out to.
Okay.
On a consumption plan, you might be limited to 100 instances in some regions.
And what about a premium plan?
You could potentially scale to 1,000 or more.
Wow, so there's still a lot of room to grow.
There is, and you can always adjust your plan as needed.
That's good to know.
It's about having options.
Earlier, we were talking about durable functions, and you mentioned the fan-out, fan-in pattern.
Yeah, it's a great pattern for parallel processing.
I get that it speeds things up, but I'm still trying to grasp the full benefit.
Okay, let's break it down.
Okay.
Imagine you have 5 tasks that need to be completed.
5 separate tasks?
Right, in a traditional workflow, you'd have to do them one after the other.
So you're stuck waiting for each one to finish.
It's like waiting in 5 different lines at the store.
Instead of just going through them all at once.
Exactly. That's the bottleneck that fan-out, fan-in eliminates.
You're running all 5 tasks at the same time.
In parallel, which dramatically reduces the total processing time.
And durable functions make it easy to manage all of that.
It handles the orchestration, the merging of results.
It's like having a team of workers tackling different parts of a project at the same time.
Exactly. Instead of one person doing everything step by step.
Much more efficient.
Definitely.
What about this async HTTP APIs pattern?
Oh, that's a great way to improve responsiveness.
How so?
Well, imagine you're uploading a large file.
Okay.
In a synchronous model, your app would be stuck waiting for that upload to finish.
I see. It would be blocked.
Like ordering food and just staring at the kitchen door.
Waiting for your meal.
You can't do anything else while you wait.
Right.
Async HTTP APIs let you start the upload and then move on to other tasks.
So you're not just sitting there twiddling your thumbs.
You're free to do other things while the upload happens in the background.
And then you get a notification when it's done.
It's all about keeping things moving and avoiding those bottlenecks.
Makes sense. Now, there's this monitor pattern that sounds intriguing.
Ah, the monitor pattern.
I'm picturing a security camera.
Well, it's similar in that it's about observing.
What exactly is it observing?
The monitor pattern is constantly checking for certain conditions,
And then what?
and then it takes action when the conditions are met.
Okay, can you give me an example?
Imagine an e-commerce site. You want to know if your payment gateway goes down.
That's critical.
It is. You could use the monitor pattern to check that service constantly,
So you'd be alerted right away.
and then you could take steps to fix the problem.
Or switch to a backup system.
Exactly.
So it's like a heartbeat monitor for your application.
That's a great analogy.
But it can also monitor for other things, right?
Absolutely. Like negative social media mentions.
To protect your brand reputation.
Exactly.
So it's not just about errors, it's about being proactive.
It's about responding to changes in your environment.
Now, this next pattern is fascinating because it involves humans.
Oh, you mean the human interaction pattern?
Yes. Why do we need that?
Well, not all processes can be fully automated,
Some things require a human touch.
like approving an expense report.
Or moderating content.
Those are great examples.
So this pattern helps integrate those human steps into our workflows.
Exactly. Durable functions can handle all of that.
Timeouts, escalations, external triggers.
It's all built in.
Can we walk through an example?
Sure. Let's say you have an online learning platform.
Okay.
You can automate a lot of the course creation process.
Like uploading content, processing videos.
But then you need an instructor to review and approve the course.
Right, before it goes live.
Durable functions can add a waiting step for that approval.
What if the instructor doesn't respond?
You could set a timer and escalate it to someone else.
And once it's approved, the workflow continues automatically.
Exactly. It's a smooth blend of automation and human interaction.
Okay, I'm really getting it now. The power of durable functions.
They're a game changer for building complex applications.
That's aggregator pattern is the last one in this source.
Ah, yes, the aggregator pattern.
It uses something called stateful entities.
Those are powerful tools for managing state.
What exactly are stateful entities?
Think of them as mini databases within your durable function app.
So they store information.
Exactly. And they can represent specific things.
Like a customer or device.
Right.
And all the data related to that thing is kept together.
In its own entity.
Instead of being scattered around.
Exactly. It's all neatly organized.
Makes sense.
And stateful entities are designed to handle concurrent access.
What does that mean?
It means multiple functions can interact with the same entity at the same time.
Without causing problems.
Right. They can read and update the data safely.
Can you give me a real-world example of how this is useful?
Sure. Imagine an IoT platform tracking thousands of devices.
Okay.
Each device could be a stateful entity,
Storing all its data.
its temperature, location, battery level.
So it's like a digital twin of the physical device.
Exactly.
And you can define rules based on the state of each entity.
Like if the battery's low, send an alert.
So each device has its own little brain.
I like that analogy.
Stateful entities bring a whole new level of organization to complex systems.
They do. It's about managing state effectively in a serverless world.
We've talked a lot about durable functions and their patterns.
They offer a lot of flexibility.
But let's not forget about monitoring and logging.
Oh yeah, that's essential.
Especially in a serverless environment.
Why do you think that is?
Well, we're giving up some control over the infrastructure.
To the cloud provider.
We need to know what's happening with our functions.
Visibility is crucial.
It's like flying a plane. You need those instruments.
To make sure everything is running smoothly.
So how do we monitor and log effectively with Azure Functions?
The good news is Azure Functions integrates seamlessly with Azure Application Insights.
Application Insights, okay.
It provides a whole suite of monitoring tools.
So we can track execution time, resource usage.
Errors, exceptions, you name it.
It's like having a team of detectives watching over our functions.
Analyzing everything.
We can catch problems before they become major issues.
And also identify areas for optimization.
So monitoring is not just about fixing things.
It's about continuous improvement.
Making our applications better over time.
Exactly. Learning from the data.
I think this is a great place to pause for now.
Yeah, we've covered a lot of ground.
But when we come back for the final part of this deep dive,
Okay.
there's one crucial topic we need to address.
I think I know what it is.
What's that?
Security. We can't forget about security.
Exactly. Stay tuned for part 3, where we'll dive into all the essential security considerations for Azure Functions.
It's going to be an exciting finale, so don't miss it.
Welcome back to our deep dive on Azure Functions. So far, we've explored how to make these functions efficient, scalable, and, capable of handling those complex workflows.
Yeah, we've covered a lot of ground.
But now it's time to talk about security.
Security is paramount.
It's like we've built this incredible machine, but now we need to make sure it's got all the right locks and safeguards.
You got it. Especially in the serverless world where your functions might be exposed to the internet.
We need to protect everything.
Our code, our data, our users.
I'm seeing a lot in these sources about securing those HTTP endpoints.
That's a good place to start.
Makes sense. That's often the entry point for a web app.
Right, and by default, clients can connect to your functions using either HTTP or HTTPS.
But we always want to enforce HTTPS, right?
Absolutely. Think of it this way. Would you rather send a postcard with sensitive information or seal it in an envelope?
Definitely an envelope.
HTTPS is that envelope. It creates that secure connection.
So it's like putting a lock on the door to our application.
Exactly.
And encrypting all the communication.
Azure Functions makes enforcing HTTPS pretty straightforward.
That's good to hear.
You can configure it to automatically redirect HTTP requests to HTTPS.
I also noticed these function access keys mentioned in a few sources.
Oh yeah, those are important for security.
What are they exactly?
Think of them as security badges for your functions.
So not just anyone can trigger them.
Right, you need the right credentials.
Each function has a unique access key.
Exactly, and you can even control the level of access granted by each key.
Like read-only access versus write access.
Precisely. It gives you fine-grained control over who can do what.
These keys sound important. We need to manage them carefully, right?
Absolutely. Treat them like any other sensitive credential.
Store them securely.
Rotate them regularly.
Avoid hard-coding them into your code.
All the best practices for sensitive information.
Okay, I see.
It's about minimizing the risk.
Now, these sources all agree that deploying functions with the lowest possible permissions is crucial.
It's a fundamental security principle.
Why is it especially important in serverless?
Well, in a traditional server setup, you have more control over the environment.
But in serverless, we're relying on a shared platform.
It's like living in an apartment building.
You have your own space, but you share certain resources.
Exactly. So you want to be a good neighbor and protect yourself?
If something goes wrong in one apartment, you don't want it to affect the whole building.
That's a great way to put it.
So we limit the potential damage by giving our functions only the permissions they absolutely need.
It's a least privilege approach.
It's like giving a contractor a key to just one room.
Instead of the whole house.
Minimizing the blast radius, so to speak.
Exactly.
Speaking of minimizing risk, these sources emphasize positive authentication.
Ah, yes, positive authentication.
They say it's the only way to truly secure those function endpoints.
It's about verifying the identity of the user or client.
So it's not enough to just have an access key.
Right, those keys can be shared or stolen.
You need to prove who you are.
Like showing your driver's license instead of just a generic key card.
Okay, I get the analogy.
Azure Functions provides several options for implementing this.
What are those options?
Well, one common approach is to use Azure Active Directory.
Azure AD.
Many organizations already use it for identity management.
So we can leverage our existing infrastructure.
Exactly. Azure Functions integrates seamlessly with Azure AD.
That makes things a lot easier.
You can specify which users or groups have permission to trigger specific functions.
That's great for internal control.
But what about external users, like customers or partners?
Yeah, they might not have accounts in our Azure AD.
In those cases, you can use third-party identity providers like Auth or Okta.
They specialize in handling external authentication.
Right, they act as a trusted guest pass system for your application.
So we have options, flexibility.
Azure Functions tries to be as accommodating as possible.
Authentication is just one piece of the puzzle, right?
That's right.
What about authorization?
Authorization is the next step,
It's about deciding what users can do once they're authenticated.
determining their permissions.
So an administrator might have full access.
While a regular user might have limited access.
Protect sensitive information.
And Azure Functions lets you define those roles and permissions,
So you can control access to specific functions.
or even parts of your code,
It's all about granularity.
giving you the control you need.
I'm also seeing this idea of deploying our function app to a virtual network.
Ah, yes, virtual networks can enhance security.
How so?
It's like placing your functions inside a secure bubble within your Azure environment.
Instead of being directly exposed to the public internet.
Right, they're tucked away behind a virtual network firewall.
That adds an extra layer of protection.
You can control which other services or systems can communicate with your functions.
It's like having multiple security checkpoints.
A security guard at the gate, a locked door, and maybe even a motion sensor inside.
I like that analogy.
It's about layering your defenses.
And Azure Private Endpoint takes it even further, right?
Yes, it creates a private and secure connection from within your virtual network.
So even traffic within our Azure environment is protected.
Exactly. It's all about minimizing risk.
Wow, we've covered so many security features and techniques.
Azure Functions offers a comprehensive toolkit.
Any final thoughts on security?
I think the key takeaway is that security is an ongoing process.
Not just a one-time thing.
Right. You need to stay vigilant, keep up with the latest threats, and proactively monitor your applications.
We all play a role in building secure systems.
Absolutely.
So, to our listener, we've now explored a wide range of topics related to Azure Functions, from those initial triggers and bindings to the power of stateful workflows and, of course, the crucial security considerations
You're now equipped to build amazing serverless applications.
that are not only efficient and scalable, but also secure and resilient.
And remember, this is just the beginning.
The world of serverless is constantly evolving.
There are always new challenges and opportunities to explore.
So what unique challenges or opportunities do you see in the serverless landscape? How will you use these tools and knowledge to build the next generation of innovative and secure applications? We hope this deep dive has inspired you to continue exploring the world of Azure Functions. 2619.